Okay, unit number 9, worksheet 1. This is a relatively easy day. Like we're going to build up to more things that are more complicated, of course. But today is a pretty easy day. The reason it's an easy day is because you already know the reciprocal trig identities. You already know the quotient trig identities. And we may not have called them that, but you know them. And the Pythagorean, you don't know those, but those aren't hard. And so you're like 2/3 of the way there. And what we do with them is really not that hard. So it's the only thing new today, even new-ish, is the Pythagorean identities. Okay, a couple things about notation here that people get thrown off with. If we cube the sine of x, we can write that as putting the cube right there. That looks funny, but that's to indicate that we're cubing the sine as opposed to cubing the x. So all of those things mean the same thing, sine of x times sine of x times sine of x. As opposed to sine of x cubed, which cubes the x and then takes the sine. Different than sine cubed of x. And the reason we write the 3 in that weird spot is to try to avoid like number 3. Like, what is that? Which one is that? The same? Are we in number 3? Are we cubing the x or are we cubing the sine? What do you think? Or do you know? It's like,
Cubing the sine of x.
It would be nice if there were some parentheses to tell me which one I'm doing. There aren't, but that's the same thing as just cubing the x and then taking the sine. Okay? That's why we don't try not to write that, because it's a little unclear. But it has a definite answer, so it's not ambiguous. It definitely has an answer. It's just confusing. Okay, in some problems, we will be asked to, there's your least favorite word in math. Prove. Okay, no panicking. This is very, very different than geometry proofs. Geometry proofs, you had that table with the statement and the reason, and you had to memorize all the definitions and theorems, and this is not like that at all. It's much easier. We'll look at proofs in a minute. We'll have to prove that one expression is equivalent to another expression. We do this using identities. There's a math word that we use a lot but don't often define. Identities are equations that are always true. Equations that are always true. So let's start with something ridiculously easy, but to illustrate the point, x plus x equals 2x. Right? That's not an equation you solve. That's like, yes, x plus x is always 2x. Why are we writing that? Well, like in algebra, that would be like an algebra proof. Prove that those are equal to each other. So a little bit more advanced would be a squared plus b squared equals c squared. That's always true, assuming a, b, and c are the sides of a right triangle. The ones we're more familiar with is something like the tangent of x. What's the tangent of x equal to? Sine over cosine. That is an identity because that's always true. Doesn't matter what x is. Tangent's always equal to sine over cosine. Okay, so we'll use those identities, less x plus x equals 2x, more trig, and manipulating the expression, fancy word for algebra, to make the sides equal to each other. So it is not a geometry proof. It is work on one side to make it look like the other. We will learn several different types of identities. You already know these two, reciprocal and quotient. We'll list them in a minute. And then this is kind of a side note. Once you've shown that two expressions are equivalent, or actually in any proof, it's customary to write QED. That's when you're really fancy and you're saying, well, I don't even know how to pronounce that. Quod erat demonstrandum, maybe. which was to be demonstrated. It means I did it. I'm finished. I did it. You dropped the mic. I proved it. We're good. My most redneck professor in college used to say that QED stood for quit and eat dinner. I finished the problem. Time to move on. Again, it's Latin for saying I did it. There it is. It's done. Reciprocal identities. These you know. I mean, I know you know them, but I think you know them. What's cosecant equal to? Be careful. Don't say inverse, because inverse means go backwards. Let's say 1 over sign. Now, I know what you mean by inverse, but that has a different meaning when we're talking about trig functions. Sine of x, we don't often think of this, but this is equally true. Sine is equal to 1 over cosecant. They are reciprocal partners. So secant's 1 over cosine. Cosine's 1 over secant. Cotangent is 1 over tangent. And tangent's 1 over cotangent. Because those are all reciprocals. Quotient, we mentioned this one already. Tangent is sine over cosine. And cotangent. It's 1 over tangent, but it's also cosine over sine. So those have a bunch of stars beside them, but you probably already know those and probably know them well. I guess the only thing to be careful about when using those is, like, if you got tangent, would it be better in a problem to use 1 over cotangent, or would it be better to use sine over cosine? And it just depends on the problem. So you have to just be careful with tangent and cotangent, because there's two things that it equals, and you just have to decide which one would be more helpful for that particular problem. All right, some easy examples with the two types of identities that we know. Prove that tangent of x times cosine of x is equivalent to sine of x if cosine is not 0. So let's write out in a more simpler form what it's saying. Tangent of x times cosine of x equals sine of x. Okay, so what could I do to show that that's a true statement? Some of you probably look at it already and you're like, yeah, I know how that works. But proofs are proving that you know how to get there. So what could I replace something with? Tangent is the same as sine over cosine. So if I replace tangent with sine over cosine, then the cosines cancel. And I get sine of x equals sine of x. QED, look at me go. Yes, sir?
Do we have to put QED?
You do not have to put QED. You do not have to put QED. Number 2. Let f and g be defined as, if we're just trying to intentionally write these as strangely as possible, f equals that thing, g equals that thing. Show that they are equal to each other. Okay, so cosecant of x, cosine of x, over tangent of x is supposed to equal cotangent squared of x. Okay, so cosecant is the same thing as 1 over sine. That's a good start. In fact, that's a really good start because now I've got cosine over sine. That is cotangent, so there's one of them. And then what else could I do? What could I replace tangent with? This is where I've got two options. But I want to end up with cotangent, so let's replace it with 1 over cotangent. So let's clean this up a little bit. So I've got cotangent in the top. And then I'm going to change it, flip it. So times cotangent over 1. And maybe this feels a little bit weird, but you have to get it all the way down to where they match exactly. You can't stop at cotangent times cotangent. I know that that's cotangent squared, but do I know that you know that that's cotangent squared? Well, of course I do, but you have to show it all the way. So you've got to get one side all the way to exactly match the other side. Even when, some of you will get right there and you're like, oh, yeah, that's it, I'm done. Like, well, no, that is it, but no, you are not done, because they have to match exactly. Once they match exactly, then you have your mic drop moment. Okay, back up at the top. I wanted to work those two simple ones first before we just talked briefly about proofs, some sort of side notes, hints on proofs. The whole point of a proof is to show your work. This is probably the most important step there, because some of you, especially on the easy ones, you'll look at that and in your brain you think, okay, tangent sine over cosine, the cosines cancel, I'm left with sine. Yep, that's true, I'm good. Like, well, I mean, yeah, but the whole point is show me how you know it works. Work only on one side. This is not really a big deal yet, because it's easy to pick which side to work on, because one side is usually pretty simple. Usually work on the more complicated side. Side of the equation. Right? Because it's usually easier to simplify something weird into something simple, as opposed to taking the other side that's something simple and trying to expand it into something weird. You look at example 1. If you tried to work the right-hand side to make it match the left-hand side, you'd be like, well, what do I do? That would be the hard way to go. It could be done, but it would be the hard way to go. So usually work on the side that's more complicated. And then lastly, I said this already, the last line has to match exactly. Don't assume anything. Right? Cotangent comes to cotangent, that's cotangent squared, but you got to show it. Okay, number 3. Number 3 is not a proof. It's more like if we start with this, which one do we end up with? I look at my answer choices, and I see some plus ones, and I see secant over secant. So I'm thinking I'm going to split this up like that. There's my plus 1, so I'm leaning toward B and C, B or C, I guess. Tangent over secant. Well, there's no way that that's equal to tangent, so it's probably B, but let's write this out. So tangent is sine over cosine. Secant is 1 over cosine. And then here's where, if you're good with fractions, life goes a little quicker for you. If you're not good with fractions, then you got to write it out and keep it, change it, flip it, and be careful who goes where. If you're good with fractions, you know that those two denominators will cancel, and that leaves me with sine of theta. Plus 1. So yeah, the answer is B. Number 4 looks crazy. Simplify that whole thing. Sine of x, cosine of x. This gets at a hint that, it doesn't always work, but if you get stuck somewhere, you can always put all the trig functions as sine or cosine. Right? You can always write any trig function as some combination of sines and cosines. So if you get something crazy, and you're like, I don't know what to do with that, well, let's write them all in terms of sine and cosine and see what happens. So tangent is sine over cosine. Cosecant is 1 over sine. secant is 1 over cosine, and cotangent, well, it's 1 over tangent, but since I've got everything in sines and cosines, I should probably go with sines and cosines. Okay, let's see, what cancels? Sine and sine, cosine and cosine, another sine and sine, and another cosine and cosine, so all of that just equals natural log of x. It's a lot of work, but a lot of that stuff canceled out. I think some people would maybe right away see that tangent times cotangent is 1 because those are reciprocals. So that's another way to kind of pair them off and see how they cancel. And in fact, cosine and secant cancel to 1. Sine and cosecant cancel to 1. However you do it, you still need to show the work to show all those things. Okay, this next page looks really long, and I don't know how to make it that long, so we'll make it short. So let's draw a triangle that was maybe taken from the unit circle. So how tall, a right triangle at that, how tall is this leg of the right triangle? If my radius is 1 and this is the angle, what's the height of that triangle? Another way to ask that is, what's the y coordinate of that point? Sine of the angle, because sine gives me the y coordinate, cosine gives me the x coordinate. Well, now I can do a squared plus b squared equals c squared. So that means everyone always starts with sine, so I'm going to put that one first. Obviously it doesn't matter because you're adding, but sine squared plus cosine squared of the angle equals 1. That is a Pythagorean identity. An identity because it's always true, Pythagorean because it came from the Pythagorean theorem.
Please stand for the pledge.
2 trig identities, it's super easy. In fact, I don't even memorize the other 2, I just find them because if I divide this one by sine squared, if I divide everybody by sine squared, that's 1 plus cotangent squared equals 1 over sine, and 1 over sine is cosecant squared. So there's your second one. And your third one, if you divide by cosine squared, so come back up here and divide them all by cosine squared. Sine over cosine squared is tangent. Cosine over cosine is 1. And 1 over cosine is secant squared. So there's your 3 Pythagorean identities. I don't memorize the other 2. I have to think about it when we get to this unit, like where does the 1 go, who's added. So my suggestion is memorize this one. It's by far the most common, and it's easy to get to the other 2 if you know that one. That picture down at the bottom is there's supposed to be some story that reminds you that tangent and secant go together. I don't know what the story is though. But what someone came up with last year, or that somewhere, the tan ones are sexy. Everyone's like, whoa, what did Mr. Wolf just say? If you're trying to remember like who pairs with who, tan 1, secant, sexy, I don't know.
That's nice.
So if you need to memorize them, there you go. I just memorized the first one and figure out the others. Okay, the last few are pretty simple because you're just using the Pythagorean identities. The blank at the top is the 3 we just did. All right, you got the worksheet. We'll work some on Monday. Have a great weekend. Go Texans.